So Pythagorean theorem, the essential question is, how can you prove the Pythagorean theorem? So what we're going to learn is Pythagorean theorem, the converse of the Pythagorean theorem, and then we're going to classify triangles. So remember, before we classified them as acute, isosceles, scalene, obtuse, all that, right? So we're going to do that again, but we're going to use the Pythagorean theorem this time, because if a triangle is not a right triangle, then isn't it either acute or obtuse? Okay, so we're going to go from that. All right, so the first thing we're going to talk about is called a Pythagorean triple. Okay, a Pythagorean triple. Well, what happened to my pen? All right, so a Pythagorean triple is 3 whole numbers that satisfy the Pythagorean theorem. So if you'll think back to the warm-up when I said, what did the first 5 answers have in common that the 6th did not? And Lizette said they were all whole numbers. All 5 of those problems from the warm-up were Pythagorean triples because they were whole numbers. There were no decimals, no radicals, no square roots, no fractions. They were just plain old whole numbers. So here is a list of some common triples. I will tell you the ones in bold. If you could just make a mental note to remember those. Okay, remember the ones in bold. Those are the most common ones. These are multiples. So if I were to multiply 3, 4, and 5 all by 2, I would get 6, 8, and 10, which would be another triple. If I multiplied 3, 4, and 5 by 3, I would get 9, 12, and 15. If I multiplied them all by 5, I'd get 15, 20, 25. So you can get an infinite amount of triples by just doing multiples, okay? 5, 12, 13 is another one. And please make note that the biggest number is always going to be the C. Okay? So for Pythagorean theorem, you have your A squared and your B squared and your C squared. So like I said, we already know this. This is new. So maybe put a star by this piece because this is new. Y'all already knew. You already knew this when you got here. I'm not teaching you that. I am teaching you when you use this with whole numbers, they're called triples. And they're going to come up a lot, okay? All right, so let's find the value of x. So my thing is, if I am looking for the hypotenuse, then we know we're supposed to add. So I'm going to do 81 squared plus 108 squared, take the square root. Which is a really large number. So it's the square root of 18225. And then I'm going to take the square root of that number. And I get 135. So it says using 1 and 2, decide whether the lengths are a triple. So what I need to decide is, well, if this is 81, this is 108, and this is 135, this is a Pythagorean triple because, and I'm going to put because the sides are all whole numbers. There are no decimals. Decimals. No fractions, no square roots. And then I'm going to make that smaller so it fits where it's supposed to be. All right. All right, so the next one, since I know the hypotenuse, I'm going to subtract this time. So subtract when you know the hypotenuse. Add when you're looking for the hypotenuse, subtract when you're looking for a leg. So this is 64 minus 16. So the square root of 48. When I take the square root of 48, I get 6.9. This time, no, because the sides are not all whole numbers. The leg is a decimal. All right, so from school, you bike 1.2 miles due south, and then 0.5 miles due east to your house. If you had biked home on the street that runs directly diagonal from your school to your house, how many fewer miles would you have biked? So what they're asking us to do is to find how far we biked, how far we would have biked, and then the difference between the two. So draw a picture. Ta-da, it's a triangle. So let's think about which side is what. It says from your school, you bike 1.2 miles due south. So that means if this is your school, you're going to go 1.2 miles south. And then 0.5 miles east. So now I'm going to go 0.5 miles east. This is the right angle. And we're going to the house. So we started at the school. We went south, and then we turned and went east. And now we're home. So how far did we bike? Well, we went 1.2 miles plus 0.5 miles. So we biked 1.7 miles. How far would we have biked if we had just cut across? So now I've got to do Pythagorean theorem. So 1.2 squared plus 0.5 squared. And since we're looking for the hypotenuse, we've got to take square root. Which is the square root of 1.69. So that would be 1.3 miles. So this distance is 1.3 miles. So we actually biked 1.7 miles. We could have biked 1.3 miles if we had just cut through, right? So they want to know how many fewer miles would we have biked. So 1.7 minus 1.3 is 0.4 miles. So we biked almost half a mile longer than we needed to. Or maybe we just weren't able to because maybe there was traffic on that road that day. Who knows? All right. So now we're going to use the converse. So given, okay, the converse says, let me go back here because I want to get it word for word. So the Pythagorean theorem states, the Pythagorean theorem describes the relationship between the side lengths of a right triangle. So if triangle ABC is a right triangle with the right angle C, then a squared plus b squared equals c squared. Remember, the converse is saying it in reverse. So I would say if a squared plus b squared equals c squared, then triangle ABC is a right triangle with right angle at C. So I'm going to have to write this because I can't type the squared. So if a squared plus b squared equals c squared, then triangle ABC is a right triangle with right angle at C. Okay, so tell whether each triangle is a right triangle. So what we have to do is take these numbers and we have to plug them into the Pythagorean theorem. So I'm going to plug them in so that I can see if this is true or not. Because if it's true, then it's a right triangle. If it's not true, it's not a right triangle. But how do you know which side is supposed to be C? Well, we already said that C is the hypotenuse. It's the longest side. So that means your biggest number has to be your C. The other two do not matter. So I'm just going to plug it in. 14 squared plus 22 squared. I want to know, does it equal 26 squared? I don't know if it does or not. I'm putting a question mark over my equal signs because I do not know if it's true. 14 squared plus 22 squared is 680. 26 squared is 676. So this is not equal, so this is not a right triangle. That's all you have to do. It's basic, it's easy. All right, on this one, it looks obvious that this is probably the hypotenuse. This, visually, it looks like that this is going to be our C, but you have to check. You cannot just assume by the picture. So what I'm going to do is type in 3 square root of 34 in my calculator, and I get that this is approximately 17. Well, if I could write 17.5, so that I can verify that this is my C. Okay. But when you're doing Pythagorean theorem, do not use the decimal. You have to use the square root. So this is going to be 9 squared plus 15 squared. Does it equal 3 square root of 34 squared? Make sure you put parentheses around it, because if you don't, then the only thing that gets squared is the 34, but I need 3 to be squared also, because I'm putting it in the calculator. So 9 squared plus 15 squared, I'm getting 306. So this side is 306. This over here, I'm going to type it in the calculator. 3 square root of 34, parentheses, and then once I get outside the parentheses, I'm going to square the whole thing, and I get 306. So this is a right triangle because these two are equal. It is true. So 3 square root of 34, remember the 3 squared is 9. The square root of 34 is 34. So 9 times 34 is 306. So just so you know. All right. So now, if it's not a right triangle, then it is either acute or obtuse. So they write them as C squared is less than. I write them different. Okay. I always put the A, because when I think of A squared plus B squared equals C squared, so then I would think of this as A squared plus B squared is greater than C squared. I'm just reading it backwards because the A squared plus B squared should come first to me, just naturally, because that's how we say Pythagorean theorem. So if A squared plus B squared is greater than C squared, then you have an acute triangle. So this would be an acute triangle because these two sides are bigger than this side when they're squared, okay? And if A squared plus B squared is less than C squared, then it's obtuse. So then I think, okay, well then that means that the C squared is big all by itself. So therefore it's obtuse. So I remember them in this order and not with C coming first. Whatever works for you, I'm not going to tell you to change it. So now what we're going to do is we're going to plug these three numbers in and we're going to see, is it equal? Is it less? Is it greater? Okay. So I know that this is the biggest side, so that has to be my C. So 90 squared plus 216 squared. What is it compared to 234 squared? So 90 squared plus 216 squared. I get 5, 4, 7, 5, 6. And what is that compared to 234 squared? 5, 4, 7, 7, 5, 6. So these are equal. So this is a right triangle. And it is a Pythagorean triple. Why is it a Pythagorean triple? Because all three sides are whole numbers. Okay, what about this one? 1 square root of 3. Well, I have to check the square root of 3, and I see that this is about 1.73. So that means this is C. So that means 1 squared plus 1 squared. What is it compared to the square root of 3 squared? Well, 1 squared is 1. 1 squared is 1. The square root of 3 squared is 3. 1 plus 1 is 2, and that is less than 3. So since the C squared, this is your C squared, since it's greater, it's the bigger side, then this is obtuse. It is obtuse because the C is greater.